Okay, come, let's go through assignment set 3, section B, question 1. So, figure 3.1 shows a 50-watt heater. So, this is a 50-watt heater. This is actually the power used to boil water in a vacuum flask for 20 minutes. This is time in minutes. This setup used to collect water on the container below the flask. Okay, so below the flask here, there's a beaker here or container that's used to collect the water. They ask us calculate the energy used, so we need to find the energy used to heat the water in 20 minutes. Formula we're going to use here, if power, time, and energy is in the equation, so we're only left with this formula here, P equals to E over T. So power is 50 watts, energy is what we're going to calculate. Now the time here should always be in seconds, but what we're given is 20 minutes, so we need to convert to seconds. Okay, so that will be the step taken, and hence 50 multiplied by 20 multiplied by 60. Okay, this equals to our energy that I want to calculate. So E equals to, if you press the calculator, you're going to get 60,000 joules. Okay, 60,000 joules. Sorry about that. Part B. Explain why vacuum is to separate the walls of the heater. Okay. So vacuum is used. Okay, what is so special about vacuum? Okay, it's because it prevents, okay, it's used to prevent, okay, what are the two ways of heat transfer that it can prevent? This will prevent conduction and convection. Okay, to be exact, let me rephrase it a little bit. Let's remove this whole sentence here. Used to prevent heat from escaping the heater via conduction and convection. Okay, so this is the explanation why vacuum is used. So do take note, the keyword here is prevent, and the two modes that it will prevent is actually conduction and convection. Now, part C, state a suitable color to use for the exterior surface of the heater. Explain your answer. Now, we talk about color here. So this actually goes into radiation already. So this whole part here so far now is on the transfer of heat. So when we talk about colors, it's really about radiation. So what color actually helps to prevent heat from escaping? Okay, so we're looking at silver color. Why? Because it is a poor emitter of radiation. So heat loss via radiation will be slowed down. Okay? Part D. Describe how water is collected in the container placed below the heater. Okay, so looking at this whole setup here, my guess, okay, this is my guess, because looking at this whole tube here, you know that when the water level goes beyond, okay, let me use blue color here. When the water level goes beyond this blue color level, okay, the water overflow and will come into the beaker. Now, question is this, why would the water overflow? Okay, most probably because when you heat up a substance, what's going to happen? It's going to expand. So my best guess for this is that as you heat the water up, okay, the water will actually expand. So because it expands, it goes beyond the maximum capacity, it will actually flow out. So describe how water is collected. So as the water is heated, okay, it will expand. And when it goes over the, let's call it the maximum height, Okay, actually you can label your diagram. You can put here like that, then label it as maximum height. When it goes beyond the maximum height, comma, it will overflow into the container. Okay, so that's the end for question 1.